Hello everyone. So in this video, we're going to see questions from errors and instruments, uh, and which were asked in the JEE Mains 2025 January attempt. Right. So there were around 6 questions, and the difficulty level is more or less similar to previous year's questions. So let us see these 6 questions one by one. Right. So let us see the first question. So the energy of a system is given as E, which is alpha cube e raised to power minus beta t, where t is the time and beta is a constant which is 0.3 second inverse. The error in the measurement of alpha and t is 1.2% and 1.6% respectively. At t equals to 5 seconds, maximum percentage error in the energy. Right. So whenever we have given a formula, we have to use that formula to find the error. So here we have given E as alpha cube e raised to power minus beta t. Now when we have a formula where we can see the product of two quantities or the quotient of two quantities, right? So here we have a product of alpha cube and e raised to power minus beta t. So what we can do in this case, you can first take the log and then use differentiation to find the relative error in e. How we can do that? So if I take log on both sides, so this will be natural log e, it will be ln alpha cube plus ln e raised to power minus beta t, right? So I can write it like this. Now here I have used the property of logarithms where ln ab is equals to ln a plus ln b. So I have used this property. Now let us further simplify this. So this can be written as 3 times ln alpha, and this can be written as minus beta t times ln e. So here I have used this property, ln of a raised to power b is b times ln a. And we know that the natural log of e is nothing but 1. So we got ln e is equals to 3 times ln alpha minus beta t. Okay. So now we got a very fine equation. Now what we're going to do, we'll differentiate this, right? So if I differentiate ln e, right, so it will be 1 by e. So if I do partial differentiation, that will become delta e divided by e, and this can be written as delta alpha divided by alpha, and this can be written as minus beta times delta t, right? So now what we're going to do, and we have to find the maximum percentage error. So when we have to find the maximum error, we have an error can be positive, can be negative. So the error in delta t can be positive, can be negative. So to have the maximum error in delta e, we have to convert this negative sign with a positive sign. So for delta e maximum, it can be written as 3 times delta alpha by alpha plus beta times delta t. Now what we have given, so we have given error in alpha and t. So delta alpha by alpha is given as 1.2 divided by 100, and delta t by t is given as 1.6 divided by 100, right? It is percentage, right? So now what we can do, percentage error, right? So if I multiply this with 100, and let me divide this with t and multiply with this t, because we have to find the maximum error at a particular time. So now let us substitute the values. So this will be 3 times delta alpha by alpha will be 1.2, and beta is given as 0.3, and delta t by t times 100 is nothing but 1.6, and t is given as 5 seconds. So we have to find the maximum error at maximum percentage error at 5 seconds. So let us write it 5. So we have, so this will give us the maximum percentage error in E. So this comes out to be 3.6, and that will be 16, 8, 2.4. So which comes out to be 6%. So option 1 will be the right answer, right? So again, a moderate difficulty question which was asked in JEE Mains. Now let us see the next question. A tiny metallic rectangular sheet has a length and breadth 5 millimeter and 2.5 millimeter. So we have given a rectangular sheet. It's a tiny rectangular sheet, and this length is given as 5 millimeter, and the breadth is given as 2.5 millimeter. Using a specially designed screw gauge which has a pitch 0.75. So we have given pitch is 0.75 millimeters, and there are 15 divisions on the circular scale. So number of divisions on circular scale is given as 15. You are asked to find the area of the sheet. In this measurement, the maximum fractional error will be x by 100, where x is. So let us say we are finding the area, right? So area. So the fractional error in the area will be delta A by A. So this we have to calculate, and it is given as x by 100. So basically we have to find the value of x. Right, so we know what is the area formula, right? Area is length into breadth, right? Again, we have a formula where we have product of two quantities. So again, you can take the log and then differentiate. So we will get delta A by A is equals to delta L by L plus delta B by B. Okay, right? And we have to find the fractional error. So basically we have to find delta A by A, which is given as x by 100, right? Now we are measuring length and breadth by using a screw gauge, which is having pitch as 0.75 millimeter, and the number of division on the circular scale is 15. So we know that what is the least count of a screw gauge? It will be pitch divided by number of division on the circular scale. So this can be written as 0.75 millimeters divided by 15. So that comes out to be 0.05 millimeters. Now we got the least count, and we are using this instrument to measure length and breadth. So we can say the maximum error which can be possible in the measurement of length and breadth will be 0.05 millimeters. So we can write length as 5 millimeter plus minus 0.05 millimeter. Similarly, we can write breadth as 2.5 millimeter plus minus 0.05 millimeter. Now from this data we can find the relative error in the length and the breadth. So this can be x by 100 can be written as 0.05 divided by 5 plus 0.05 divided by 2.5. Now let us multiply throughout by x. So x will be 1 plus 2. So this comes out to be 3, right? So 3 is the answer of this question, right? Same type. So 3 is the answer. Now let us see the next question. Maximum percentage error in the measurement of the density of a wire is, we have given mass and the error in mass, we have given radius and the error is also given, we have given length of the wire and the error is also given. So we can say this is m, so this will be delta m, this is r, this will be delta r, this is L, and this is delta L. Now first of all we have to write down the formula of density of a wire, and here we're going to treat a wire like a cylinder. So there is a wire and the radius is r, length is L, and its mass is m, right? And density is given as, density is mass times mass upon volume, and volume of a cylinder is like cross sectional area times the length, and cross sectional area is pi r square and the length is L. Okay, so we got this relation. Here again we have a quotient of m and pi r square L. So again we can use the same approach. Where pi is constant, there is no error in the measurement of pi. So pi is constant, so we are left with m, r square and L, right? So we can use the same logic, and it will give us delta rho by rho is equals to delta m by m plus 2 times delta r by r. So why I'm taking a positive sign here? Because delta r can be positive, can be negative, and we want, whenever they ask about the error, and usually they ask about the maximum percentage error, so we have to convert negative with the positive sign, plus delta L by L, right? Right, so so let us multiply this with 100. So this also with 100, This is also 100, right? So it will be 0.003 times 100 divided by 0.6, 2 times 0.01 divided by 0.5 times 100 plus 0.05 times 100 divided by 10, right? So this will become 0.3 by 0.6 plus 2 by 0.5 plus 5 by 10. So this will give us 0.5, this will give us 4, this will give us 0.5, right? So this comes out to be 5%. So option 3 is the right answer. Now let us see the next question, which is based on Vernier caliper, and again it's a like true and false question, right, where we have to check which of these two statements are correct or false, right? So statement 1, in a Vernier calipers, one Vernier scale division is always smaller than one main scale division. So whatever Vernier caliper which are available in the market and which we are going to use, right, when you get into when you pursue your engineering, right, the Vernier caliper which you're going to use will have Vernier scale division will always be smaller than the main scale division, right? So by that logic we can say the statement 1 is correct. Look at the statement 2. The Vernier constant is nothing but the least count of the instrument, right? So Vernier constant of the Vernier caliper is given by one main scale division multiplied by the number of Vernier scale division. We know that the least count is given as the difference of the main scale division and the Vernier scale division. So statement 2 is false. So we can say statement 1 is true, statement 2 is false. So option 2 is the right answer. Now let us see another question based on errors. A physical quantity Q is related to 4 observables A, B, C, D, and D. So this formula is given to us, and we have given error in A. Basically, we have given the value of A as well as the error in A. Similar, the same data is given for B, C, and D respectively. The percentage error in Q is x by 1000, where x is, right? So very basic question. Here we have product as well as the quotient. So we're going again use the same logic. The relative error in Q will be 1 times delta A by A plus 4 times delta B by B. Because why 4? Because the exponent of B is 4, plus 1 times delta C by C plus 1 times delta D by D. And we have to find the percentage error. So we have to multiply everything with 100, right? So left hand side will give us the percentage error in Q. So let us substitute the value. So 100 times delta A is 3 divided by A, which is 60, plus 4 times delta B is 0.1 divided by 20 times 100. Delta C is 0.2 divided by 40 times 100. Delta D is 0.1 divided by 50 times 100. So let us simplify this. So it will be 5. So we get this will be 2 and 20. So that will be 0.5, and this will be 10, 100, right? So it will be 10, 1 by 5. Let me again check. 0.1 upon 50 to 0.2. So this comes out to be 7.7, and this value is given as x by 1000. So x comes out to be 7700. So 7700 is the answer of this question, right? So let us see the next question. The least count of the screw gauge is 0.01 millimeter. So that is the least count. If the pitch is increased by 75% and number of division on the circular scale is reduced by 50%, the new least count will be dash times 10 raised to minus 3 millimeter. So basically we are altering pitch as well as the number of division on the circular scale. So if I denote pitch with P and the number of division on the circular scale will with N, the original least count of 0.01 millimeter will be P by N. Now what we're going to do, we are increasing the pitch by 75%. So the new pitch, let us say P prime, that will be P plus 75% of P. So which is nothing but 1.75 times P. And the new number of divisions will be less than, so the number of division is reduced by 50. So that will be n minus 50% of n. So that comes out to be 1 minus 0.5 times n, which is 0.5 n. Now let us find the new least count. That will be p prime upon n prime. So that comes out to be 1.75 p divided by 0.5 times n, right? So this will give us 7 by 2 times 0.01 millimeter, because p by n is 0.01 millimeter. So this comes out to be 3.5 into 10 raised per minus 2 millimeter, or we can also write this as 35 into 10 raised per minus 3 millimeter. So the blank, what we have to fill in the blank is 35. So the answer will be 35. Right, so these are the questions which were asked in JEE Mains 25 January attempt. So I hope you like the video. So if you want to share anything, you can write in the comment section. Thank you.